Hello everyone, it's me Arvind catching you on another Tutor Edu's lecture video. Okay, we have come to the last part of our Form 4 Chapter 1 functions video, which is the properties of inverse function. Okay, we are still in the inverse function subtopic. We have covered the introduction and we also covered the horizontal test, and now we have come to the properties of inverse function. Okay, so allow me to go through some of the key properties of the inverse function, guys. Okay, so from here, given that f and then the composite of f inverse x, so when this occurs you will get back your x. Okay, so let me box this. So when it involves a composite of function and an inverse function, you will get back the object. So let's say when you are mapping 2 into the composite of inverse and a function, so you get back the 2 again, and the same thing as composite of inverse and the function, so you get back the object as well. So let me box this. So the order doesn't matter, guys. Let's say if the inverse comes first or the function comes first, it doesn't matter. So when this composite function occurs, you will get back the object. So let's say your object is x and the composite of the function and an inverse, or inverse and a function, so you get back the object x again. So let me just show you a quick example regarding this. So given that fx is equals to 2x plus 5, okay, so let's say we're going to find the inverse of this. Okay, so to find the inverse of this, okay, so let f inverse x is equals to y, okay, and then from here fy is equals to x. All right, so from here the y you substitute into the function fx, so from here it will become 2y plus with 5 is equals to x. Okay, so from here we need to form equation of y in terms of x, guys. So from here y is equals to x minus 5, and then you divide with 2. Okay, if this step you can't do it straight away from here, it is okay for you to do step by step, guys. Okay, you can add an extra step over here. For example, 2y is equals to x minus 5. Okay, so from here you get your y is equals to x minus 5 divided with 2. Okay, since in the earlier of our working we let the f inverse x is equals to y, so from here you get your f inverse x is equals to x minus 5 divided with 2. Okay, so this is the first step. So now you're going to prove that the properties f inverse x is equals to x. Okay, and then followed by this second one as well. Okay, so from here let us begin with the first one. So from here let us start. So f inverse x, so from here your f inverse x you get is x minus 5 divided by 2, so you just substitute over here, okay, in a bracket, x minus 5, okay, divide with 2, close bracket. Okay, and then this x minus 5 divided with 2 will be mapped into the function fx over here. So as you can see here, the function fx is 2x plus 5, so we're going to map this x minus 5 divided with 2 into here, guys. So from here 2 in a bracket, x minus 5 divided with 2, okay, and then you plus with 5. Okay, so let me underline the fraction line. Okay, so from here the 2 and 2 will get simplified. Okay, you're only left with 1. So now you only left with x minus 5 plus with 5. So negative 5 plus with 5, you only get 0. Okay, so you left with 0 here. So x plus with 0, so technically you get back x. Okay, so this one I'm expressing in terms of variable. How about in terms of number? Okay, let's say instead of putting x, I put number 2 here. Okay, let's say f inverse 2. Okay, so from here, f in a bracket 2 minus 5 divide with 2. Okay, so from here 2 minus 5 divide with 2, you get is negative 3 over 2, right? So from here f you get is negative 3 over 2. So this negative 3 over 2 will be carried into the fx over here. So from here 2 in a bracket negative 3 over 2. Okay, and then plus with 5. Okay, so this 2 and 2 will get cancelled off, so 2 you get 1, so here you get 1, so you're only left with negative 3 plus with 5. So negative 3 plus with 5, you would get your answer is 2. You see, you get 2, you put 2, you get back the 2 again. Okay, so it is proven that the f inverse x is equals to x. So the arrangement doesn't matter, guys. Okay. So either way, the function comes first followed by inverse, or the inverse comes first followed by the function. You will get back the x again, which is the object in this case. Okay. You know what? Let me just delete this. Delete this. Okay. Underline. Okay, now it looks better. Oops. Okay, so let me just show you one more properties. Okay, let me just draw a big graph. Okay, so now what I'm going to do is, so using the fx and f inverse, I'm going to sketch a graph. Okay, so from here you get our fx is 2x plus 5, right? So let me just copy and paste over here. Okay, and then our f inverse we get is x minus 5 divided with 2. So you also paste it here as well. So this f inverse x you can arrange such a way that it is become half x minus 5 over 2. At least it will be easier for you to sketch the graph. Okay, so from here I'm going to start by sketching the graph of fx. Okay, so from here let me start with 5. Okay, and then 7. Okay, 1. Okay, so the x-intercept is negative 2.5. So in this case is, okay, you can write is negative 5 over 2, or if you want to write negative 2.5 also can. Okay, so for your convenience I just write here negative 2.5. Okay, so let me just sketch the graph. The 2.5 I just move it over here. Oops. Move it over here. Okay, now it's better. So this is the graph of fx. Okay, so by the way, this is just a sketch, guys. Okay, so this is the fx. Okay, now what I'm going to do is I'm going to draw the f inverse x graph now. Okay, so for the f inverse x, so your y-intercept is negative 5 over 2. So in this case is negative 2.5. Okay, so negative 2.5. Okay, your y-intercept is, okay, so your x-intercept in this case is 5. Okay, so let me just extend this. Okay, so your x-intercept in this case is 5. Okay, so you just draw another straight line over here. Okay, okay, so this is the graph of f inverse x. So where your fx here is equal to 2x plus 5, your f inverse x is actually equals to half x minus 5 over 2. Okay, you might be wondering how I get this negative 2.5. Okay, this negative 2.5 I get from the y-intercept. Okay, you set your x equals to 0, you get your y equals to negative 5 over 2. So negative 5 over 2 you convert into the decimal, you get is negative 2.5. Okay, for the x-intercept you set your f inverse x, in this case equals to 0, and that's how I get my x is equals to 5. So 5 over 2 minus 5 over 2 you get 0. So that's how I get the 5 here. So this is your f inverse graph, and this is your wait on guys, and this is your fx graph. Okay, now what I'm going to do is I'm going to draw a graph with respect to origin, y equals to x. Okay, so let me just use a dotted line. Okay, okay, so you should act as a mirror, guys. Okay, if you take a note at this, so this function fx should act as a mirror for f inverse x. Okay, so and this dotted line, okay, let me just write the graph of this dotted line where your y is equals to x. So when y equals to 0, your x equals 0, your y equals to 1, x equals to 1. Of course, this sketch is not according to scale, but if it is according to scale, you should get exactly a mirror, guys. So this fx is the mirror of the f inverse x. Okay, they're like a reflection. So this y equals to x is act as a reflection. So what does this mean? Okay, let's say for example, in your fx, you have a coordinate of 0, 5. Okay, you have a coordinate of 0, 5 here, and this is the straight line of fx. Okay, if you can't see it clearly, maybe I can extend a bit further. Maybe you can see the mirror. Okay, fx. And guess what is the coordinate for f inverse x? So in fx it is 0, 5, and for the f inverse is the other way around, 5, 0. See, 5, 0. F inverse x, your x will be the 5, your y will be the 0. And when you take a look at the fx, it is 0, 5, but then when you take a look at the f inverse x, is the other way around. They just interchange the position, and that's why it is proven that the fx is just a reflection of f inverse x with respect to the origin. the y equals to x. So this is one of the important properties, guys, of the inverse function. Okay, it is the reflection with respect to y equals to x. Okay, for your normal function and the inverse function, basically your y equals to x act as a reflection. Okay, when your fx, you have the x and y of 0 and 5, your f inverse x will be 5 and 0. This is one of the example. Okay, another example, you can use the intercept also. So where you take fx, okay, in this case you have your x-intercept 2.5, 0. Guess what will be the inverse? Okay, it become the y-intercept instead, 0, negative 2.5. So your x and y, they interchange, they swap the place into one another. So that is the explanation behind this sketch, guys. Okay, this is one of the important properties that you need to learn. Okay, the relationship between a normal function and a inverse function. They are just a reflection of y equals to x with respect to y equals to x. Okay, and we have already proved it using our coordinate system over here. Okay, guys, so this is the explanation behind this, and I hope you were able to catch me up. So if you don't understand, so let me just repeat it one more time. Basically fx, it is just, basically fx and the f inverse x is just a reflection with respect to y equals to x. That means that your f inverse x is just a reflection of the normal function. They are just reflecting into one another. Okay, so let me just scroll it up. Okay, so that is all for the properties of inverse function lecture video. Okay, I hope you understand the explanation that I've given to you. If you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming AdMaths lecture videos in the future, and not to forget to share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.